Now, we can solve system of equations by using the inverse of a matrix. This is called as matrix inversion method. Now, we have three types of equations: consistent equations, inconsistent equations, and dependent equations. Consistent equations are: a system is said to be consistent if its solution exists. If determinant of A is not equal to 0, then the system is consistent and has unique solution. Inconsistent equations: a system is said to be inconsistent if solution does not exist. That is, if determinant of A is equal to 0 and adjoint A, B into B is not equal to 0, then the system is said to be inconsistent. Dependent equations: if the system of linear equations has infinite number of solutions, then the equations are said to be dependent. If determinant of A is equal to 0 and adjoint A into B is equal to 0, then the system is consistent and has infinitely many number of solutions. Now, the given system of equation is x minus y plus z is equal to 4, 2x plus y minus 3z is equal to 0, x plus y plus z is equal to 2. Solve for x, y and z by matrix inversion method. Now this can be written as Ax is equal to B, or this implies x is equal to A inverse times B. Now let us rewrite this equation as a matrix form. So A is equal to 1 minus 1, 1, 2, 1 minus 3, 1, 1, 1 into x, y, z is equal to D is 4, 0, 2. So it is clear that A is 1 minus 1, 1, 2, 1 minus 3, 1, 1, 1, and x denotes x, y, z, and B is 4, 0, 2. Now let us see if inverse exists. For the matrix to have an inverse, the determinant of A should not be equal to 0. Now let us find out the value of the determinant. That gives you 1 into 1 plus 3 plus 1 into 2 plus 3 plus 1 into 2 minus 1, or 3 plus 1 is 4 plus 5 plus 1, which is equal to 10. So this is not equal to 0, therefore inverse exists. Now to find out the inverse, let us find the adjoint of A by the matrix inversion method. So adjoint of A. To find the adjoint of A, A11 is equal to minus 1 to the power of 1 plus 1, M11, which is equal to 1 into 1 minus 3, 1, 1, which is equal to 1 into 4, which is equal to 4. Next is A12 is equal to minus 1 to the power of 1 plus 2, M12, which is equal to minus 1 into 2 minus 3, 1, 1, which is nothing but minus 1 into 2 minus of minus 3 is plus 3, that gives you 5. So that gives you 5, which is equal to minus 5. Next is A13 is equal to minus 1 to the power of 1 plus 3 M12, which is equal to 1 into 2 1 1 1, which is equal to 1 into 2 minus 1 is 1, which is equal to 1. Next, let us find out the second row. For the second row, A21 is equal to minus 1 to the power of 2 plus 1 M1, which is equal to minus of minus 1 into minus 1 1 1 1, which is equal to minus of minus 1 will give you minus 2, that is equal to minus of minus 2 is plus 2. So minus 1 into minus 2, which is equal to plus 2. Next is A22, which is equal to minus 1 to the power of 2 plus 2 M22, which is equal to plus 1 into 1 1 1 1. Clearly this is equal to 0. A23 is equal to minus 1 to the power of 2 plus 3 M23, which is equal to minus 1 1 minus 1 1 1, which is equal to minus of 1 plus 1, which is equal to minus 2. So minus 1 into 2, which is equal to minus 2. Next we'll go for the third row. A31 is equal to minus 1 to the power of 3 plus 1 M31, which is equal to 1 into minus 1 1 1 minus 3, which is equal to 3 minus 1, which is equal to 2. So 1 into 2, which is equal to 2. Next is A32 is equal to minus 1 to the power of 3 plus 2 M32, which is equal to minus 1 1 1 2 minus 3, which is nothing but minus 1 into minus 3 minus 2 will give you minus 5, which is equal to plus 5. Finally, A33 is equal to minus 1 to the power of 3 plus 3 M33, which is equal to 1 into 1 minus 1 2 1, which is equal to 1 into 1 plus 2, which is equal to 3. Therefore, it is 3. Therefore, adjoint of A is equal to 4 minus 5 1 2 0 minus 2 2 5 3. Now let me transpose this. That will give you 4 2 2 minus 5 0 5 1 minus 2. Now you know A inverse is equal to 1 by the determinant value of A times adjoint of A, which is equal to 1 by 10 4 2 2 minus 5 0 5 1 minus 2. Now to find the value of x, y and z, we know that A inverse of B is equal to x. So that will give you x, y, z is equal to A inverse is 1 by 10 4 2 2 minus 5 0 5 1 minus 2 3 into 4 0. Now, let us multiply this. That would give you 4 4s are 16 plus 0 plus 4. 4 5s are 20 minus 20 plus 0 plus 10. 4 into 1, 4 minus 8. 3 2s are 6 plus 6, which is nothing but 1 by 10, 20 minus 10. Sorry, this is 0, children. This is 0. So, this is 4 minus 0 plus 6. So, that will give you 10. Finally, this therefore x, y, z is equal to 2. 20 divided by 10 is 2. 10 divided by minus 10 is minus 1. 10 divided by 10 is 1. So therefore, x is equal to 2, y is equal to minus 1, and z is equal